Hey humans, how's it going? Susan Ruth here. Thanks for listening to another episode of Hey Human Podcast. This is episode 332, and I had a conversation with Dr. Maurice Robkin. Maurice is a scientist, engineer, and considers himself, quote, nowhere near the physicist Feynman, Hawking, or Einstein were, unquote. Well, okay, sure, that's the highest of the high bars, right? But, I think he's pretty damn smart myself. He's also the author of the Margaret series about a governess turned kick-ass pirate, and he's currently working on his 7th book. He also happens to be my dad. We chat about the edge of the universe, time, writing, love, and a whole lot more. And I'll tell you, during this conversation, I marveled in love of him. I mean, obviously he's my dad and I love him, but just he's so precious to me. And I know as a much older man, his time on this planet is limited. And I'm just so thankful that I'm able to record talks with him. And I'll cherish every word as long as I live, So I'm so excited to share him with you all. Okay. For more episodes like this one, check out episode 100, The Origin Stories, with both of my parents, episode 83 with Donnie Stedman, episode 106, When the Big Apple Bites Back with yours truly, and episode 127 with Dr. David Calkins. Looking for older episodes of Hey Human? Apple Podcasts now show all the episodes along with blurby.com and of course heyhumanpodcast.com websites. So if you find on your app that it only covers up to 300 episodes and you want to know what happened in that first year, definitely go to those other places and you will find every episode from the very beginning. In other news, check out heyhumanpodcast.com for links that will let you deep dive to learn more about my guests and everything that they do and the show in general. Check out susanruth.com to learn more about me and follow Susan Ruthism and Hey Human Podcast on social media. Also, check out my new relationships and sex show, Are We There Yet? With sexologist and healthcare practitioner Mara Edelman. It's on YouTube at youtube.com/Are We There Yet Podcast Show. Thanks for listening. Take care, be love, be kind to one another. Here we go. Dr. Maurice Robkin, also known as Martin March, that's your pen name that you write under. Welcome to Hey Human.
Thank you.
Good to see you.
Yes, and you too.
Usually we're doing this over Skype, so Zoom is a new way to go. And this time I'm going to grill you.
All right, well, make sure it's grilled the same on both sides, so go ahead.
Well, you have been on the show before. In the first year of my having Hey Human, you were a guest, and that was really fun to celebrate. I believe it was to celebrate my year 1 anniversary.
As a podcaster.
Yes, that's one of the things I do, as a podcaster.
Yeah. I remember the occasion. I don't really remember what we said or talked about, but that's all right also.
I wanted to get you on the show again and just have one of our usual talks. We talk about so many different kinds of things, many topics, generally science and space and writing. You grew up in New York and in California.
I was a little kid before I came to California, yes.
Did you have a love of books back then and writing?
Not writing, so love of books, yes. And when I was older, in junior high and so forth, I started reading science fiction books. Got very interested in science fiction and science in general. But when I was in high school, in Hollywood High in California, I took classes in creative writing and discovered that I enjoyed that and learned how to write a little bit there. I really didn't learn how to write the way an author does. I mean, I learned how to at least use the language a little bit. I learned grammar and syntax and all that stuff. And when I grew up, I seemed to have a knack of writing good English and, getting ideas across reasonably well.
Didn't you say that at MIT that was encouraged? Was it Caltech? There, you said that one of your universities that you were
what I said, I believe, is that to get into Caltech, which is where I was as an undergraduate, you had to take 4 entrance exams. And in one of them, you had to write an essay for 4 hours, an essay on a couple of topics they gave you, for example. One of the topics they gave was, I forget the name of it, but I think it was about transportation or air flying, air or travel or whatever. And I wrote good English, apparently, and so forth. And they did have a requirement that all undergraduates, all freshmen coming in, had to take an English class. And I was exempted from that, excused from that, because I showed in my essay that I already knew how to write English. And I guess I was lucky because they sent out professors to all the applicants, all the potentially acceptable applicants, to see what they were like, to interview them face to face.
This is at Caltech they did this?
Yeah.
Wow.
And it turned out that the professor that came to see me was the professor of English. Now, whether that was coincidental or because of the exams, I don't know. But in any event, I was accepted to Caltech and sort of went from there.
To get into MIT, did you have to rely on any of those skills as well, or was that more mundane engineering and science type stuff? Not mundane, but you know what I mean.
To get into MIT as a graduate student, the thing you needed was your academic undergraduate record, any other education you had, and recommendations from appropriate people. And I guess I must have had enough of that because I was admitted. And I went to MIT as a graduate student in nuclear engineering.
Did you enjoy your college years?
That's an interesting question. And as it turned out, I wasn't really smart enough to do it without trying hard, without really struggling.
You always say that, but you're one of the smartest people I know.
Well, but you don't know the smart people I know.
Good point.
And the point is and was, there were some of those students who literally understood instantly what was being taught to them and never had a problem with any of the exams or any of the homework, didn't have to really work that hard. And the kind of person I always like to think of as that sort of person is what I can imagine Richard Feynman was like when he was an undergraduate, who are so smart that he was already doing the mathematics at the graduate level when he was a freshman.
As a kid that grew up in the realm of science fiction and fantasy and things like that, were you always in the back of your mind as a kid thinking, well, what is possible beyond what we know in science and technology? Do you think that created a path for you, or was it more happenstance?
A path in what sense? Of becoming one?
That you would follow in the sciences.
I don't know that I would say that it was something that directed me to that. It was something that was consistent with my interest in science and the fact that I found science fiction very, very exciting to read. And even as a kid, I was involved. I had joined the Los Angeles Museum of Invertebrate Paleontology student program. I used to go on field trips looking for fossils in the hills around Hollywood. And go to classes there and so forth. I did as a high school student, as a junior high school student, and very well in science and math, and even in college, in undergraduate college, I did reasonably well, which at a school like Caltech means I was probably doing better than most of the students as a rule in other places, but not necessarily, because I'm sure in Berkeley and UCLA and so forth, there were students who were going to be these sorts of stars. But I'm just saying, generally speaking, a degree from Caltech maybe counted more in the application to MIT than perhaps social equity would account for, would be comfortable with.
You grew up quite poor, so the idea that too you had to work that much harder because you needed a scholarship.
Well, I never thought of it in those terms, but it was true that the fact that I got a scholarship in my first couple of years certainly made it easier, because back then, of course, when I matriculated at Caltech was in the fall of 1949, the annual cost at Caltech was $600. And that was a lot of money in those days for people like us. I mean, I don't know how many zeros you would have to tack on the end of that to represent what the present day tuition at a place like that is. But in any event, you did manage to get scholarships and or fellowships, both at Caltech and MIT, which made it possible to go to school there.
Did your parents appreciate how hard you'd worked and the fact that you got a scholarship?
That's not a topic I really can contribute much to. I don't know. Communication between me and my parents was, let's say, not very smoothly flowing, and so forth. So no, I grew up pretty much as a parented orphan, if that's the word. Not because I didn't have loving parents or parents who loved me, but we never talked about anything because they were immigrants. They really didn't understand what was happening, what I was going through. And in a sense, I think, for example, my father was a little either jealous or resented the fact that he was forced to leave college when the Depression hit, and he was never able to get his degree. He was studying to be an accountant, a CPA, a certified public accountant. And the Depression hit, and everything changed. People just could not afford that. Even going to a school like City College of New York, you couldn't afford it. You couldn't afford to live. You couldn't afford to eat without any income. So, and he had a family to support.
Do you have recollections of the Depression and being hungry or being poor? Did it occur to you? Never had any impression of being hungry.
And as a small child, you don't have the references to be thinking of yourself as poor. We lived in a one-room apartment with for four people. You know, there was just a bed sitting room with a Murphy bed, a bed for me, and a cot for my kid brother, my father and mother, and me and him. And as a child, even all the way through junior high and well into high school, I never thought of myself as poor. I just thought of myself as in my environment. I mean, I never had anything to compare it to.
Mm-hmm. Did you drag your little brother around with you when you were both of age that would be appropriate when you would go on, rock finding missions or, looking for fossils, things like that?
No, I took him a couple of times to go fishing in Santa Monica, and to the movies from time to time when I was in college and he was still in high school. But I'm considerably older than my brother was, so I was almost a generation later, not quite, 6.5 years, but you know how that goes.
I do, as I am the youngest of a much older sibling too, in fact, yes. And your little brother passed away a couple years ago.
He did. He passed away. He was 80 when he passed. And when he was 80, I was 86 or 87. So that was 5 years ago.
And he died of
a form of bone cancer, which he thinks was brought on because when he was a kid and he was in high school, he used to do a lot of work around car engines and so forth, and a lot of organic solvents. And back then, in the 50s, late in the 60s, there wasn't all that fuss about that kind of carcinogens. And he suffered from this for a long time. He got treatments and that held us sort of at bay for a long time. They finally stopped working, and he finally succumbed to it after Rochelle died, a couple of years later.
Yeah. I know that he missed her greatly. I think
yes.
He and I had a couple of interesting conversations in the hospital where he talked about seeing her again and looking forward to seeing her again, which, to be honest, surprised me because I never knew that he had that philosophy, and maybe that was a philosophy that came on later in life for him.
I'm sure when that is facing us, that kind of termination, we grasp onto whatever we can to make it easier for ourselves to not tear ourselves apart in contemplating what it means to be terminated.
Do you think about death much?
Not much, no. I don't feel like I'm close at the moment.
Me neither. Good.
But that's not to say I don't recognize that my body is a good deal more aged than it used to be. My spine is collapsed and so forth. And my sleeping is not like it used to be, and so forth.
You have scoliosis that has certainly progressed.
Well, I've lost something like 5 inches since my full growth, 5 or 6 inches. And that's all from the fact that my spine is all bent over. But I'm still able to get up, do everything I need to do by myself. The only thing, my balance is affected and such like, and I have the usual aches in places that I suppose I should, but otherwise everything's working. I discover I can't talk for very long without getting dizzy, only because it takes a lot of oxygen to talk.
Well, please tell me if you start getting dizzy, and we'll come back. We don't have to.
So there are various things that get wrong with a person, and different people have different issues. So,
have you contemplated what lies beyond?
Well, I'm too much of a rationalist and too little of a religionist to really think there's anything beyond.
Do you hope there is?
That's sort of pointless.
How come?
To hope for something that's like wishful thinking is sort of silly. I mean, it's a waste of effort.
You don't think it brings comfort?
No, I don't. I don't.
You and I still have a pact that when you go, you're supposed to reach out to me if it is indeed possible.
Well, it seems to me more likely you reach out to the dead from what I can gather. So I'm not sure which way that's going to go. And if you do reach out and get a response, it's not clear to me whether you're talking to yourself or actually talking to me, because as far as I know, once the brain turns into soup, there is nothing left to communicate with.
You never know.
I don't know, obviously. Nor when I do know will it do me any good now.
Do you still look up to the sky and wonder, does the universe still hold your attention?
What do you mean?
Well, you and I have had so many conversations over the years about what is out there and the edges of things. And
oh, well, speculate. I'm convinced that there is sentient life out there, but I'm also convinced it's so far away that interacting with them or even proving it is conceivable. Interacting with them, I think, is inconceivable. I think Einstein has said, you're really looking for something that's more magic than science. Now, he didn't say that in so many words, but he certainly implied it with his theories of relativity. So getting to those places would require so many human lifetimes that by the time any remnants of humanity in a ship would get to a place like that, there'd be no way of letting the folks back home know.
right, they'd all be long gone.
Well, even trying to send them a radio message wouldn't be very useful, because the probability of the location of a planet that had evolved sentient beings would be so far away that it would take hundreds, maybe thousands, maybe millions of years for a signal to get back from there to here. And unless we can find, for example, any kind of life in places like Europa, or traces of leftover life on the moon or on Mars or wherever, Mars is a good bet. Europa having an ocean under the ice is a good bet. Again, the probability, even with the Drake equation, the probability of finding sentient life, it's easy to use the Drake equation, but when you come right down to it, without actually, like any other theory, you have to be able to disprove it, which means you have to either show that it's not possible, or have a situation where every experiment you do does not produce a positive result, or if you're lucky, finding and doing an experiment that seems to confirm the theory, which doesn't necessarily prove it.
Could you explain what the Drake equation is?
Yeah. Drake said, let's consider if we can estimate what is the probability of finding sentient life outside of our own planet. And he said, well, let's first consider how many stars there are in the known universe. Then let's consider what's the probability for a star having planets. What kind of stars do this? And there's a certain class of stars that are likely to have planets. And so you multiply the first number by the second, you get an estimate of how many stars there are in the universe that are able, in principle, to have planets. Then you think, how many of these planets would be of the sort to harbor life? When we look at our own solar system, we have 8 planets now, and Pluto being demoted, and we have 1 planet that currently has life on it that has evolved to what we laughingly call sentience. So, all right, if you put that number in, let's say 1 out of 8, 1/8. So you multiply the first 2 numbers by 1/8. And then you say, okay, what's the probability that a planet that can sustain life actually begins to have life. What are the conditions? Well, you got to have the right substrate, the same mixture soup of molecules that generates that. And he thinks about, or he thought about, that experiment that was done where a couple of guys put in a beaker that a soup of various chemicals. They put an arc discharge in there and fired it off like lightning, and went back and analyzed the soup and discovered they had polymers of those amino acids that actually looked a lot like they were on their way to starting to evolve into more complicated polymers, proteins, and so forth. And until those polymers learned how to replicate themselves, i.e., become alive. And so you look at what an estimate of probability is of that happening, and you multiply the first set of numbers by that, and on and on and on. And you get through all the estimates of all the things that are necessary, including the probability that you learn how to make weapons and wind up annihilating your entire civilization, your entire planet, and all that stuff. And he came up with a number that said, given all that, there should be thousands, if not millions, of planets with sentient life on it. And of course, that blew everybody's mind. But the trouble is, it's only a hypothesis, a conjecture. So how do you go about turning it into a scientific theory? You set up experiments to disprove it, or to try to replicate it, or something like that. And so right now we shoot off rockets and we go to Mars, and we're trying to go to Mars, and we're talking about going to Europa, and we're going back to the moon, and we're digging up the dirt and looking for traces of organic life there and so forth. And we're looking at the radiation that comes from the stars for the kind of signals that an atmosphere that harbored life would have in it, things, organic molecules of one sort or another. And, we're in the process of seeing if we can find anything. But so far, it's just a conjecture. So getting back to your question, do I think it's possible there are living things out there? Yeah. I think the Drake equation is a pretty good hint that there probably are. Do I think actually that there are? That remains to be seen.
Do you think within the next 100 years we'll colonize Mars?
What define colonize? That will set human beings down on Mars? Yes. That will have people actually living there? No.
Because of the atmosphere?
There isn't any.
Exactly. Well, that's what I mean. Because of the lack.
It's extremely thin. As far as we're concerned, it's basically a vacuum. I mean, the pressure of the atmosphere there is so small.
It's also real cold.
and very cold, yeah, except in the sun, which at least is no worse than, let's say, Alaska in the winter, It's, but there's ice on the planet, on the poles.
It snows, right? It snows on the poles.
Which means there's water. Mm-hmm. And there's probably a lot of oxygen in the rocks as oxides. But Mars has no magnetic field.
Oh, so there's nothing to protect.
Solar radiation, right. Which means that if there was life there, it was probably only allowed to develop to a certain point, but on the surface, without an atmosphere, there's no protection against the radiation from the sun. And so that's, fortunately, the Earth has a magnetic field. If we lost the magnetic field, it would be real bad news, because the solar wind would blow our atmosphere away. As it is, solar particles get shunted to the poles, and they get burnt up or we lose their energy in the atmosphere. So this is one of those elements of the Drake equation. What's the probability? Well, we've been lucky. Other places might have planets that could have supported life, but don't have a strong enough magnetic field to protect themselves from the sun. The other thing in the solar system that's protected us and allowed us to develop is Jupiter, because it's our big wall against stuff coming in from outside the solar system. It's such a huge planet that its gravitational field acts as a big net to catch all those rocks that keep coming in.
It's Earth's bodyguard.
Well, I think it's Earth's shield. And again, what's the probability of a planet living, and has to be in the Goldilocks zone? That's another term in the equation. What's the probability that a planet with all the other characteristics happens to be circulating around its primary in its Goldilocks zone, where it's not too hot, not too cold?
For a person that is so in touch with science and science fiction as well, why do you think it was that you were drawn to a historical type story in your writing instead of this other kind of thing that you grew up in loving?
Well, it's very simple. It was a response to that challenge that speaker put up. Well, once it got started, it was just too easy to keep going. The first book practically wrote itself. So did the second book. By the time I got to the sixth book, I had to be a little more participatory.
I think Margaret is she's a badass character. I'd like to think that I have a little bit of a model of her.
Well, it may be. I've never consciously thought about it in those terms, but I could see you. Well, you certainly, as far as I can tell, don't. What's the word I'm looking for? Don't tolerate? No, that's not the right word.
I don't suffer fool.
Suffer fools, thank you. Yeah. Don't suffer fools gladly, yes. Yeah. And I can see you with a sword in your hand, and I know you've had some bad personal experiences with men.
Love, sure.
Just like Margaret has done. So yeah, I mean, who knows what the knowledge of people one has interacted with, whether family or otherwise, contributes to giving characteristics to a character.
And no spoilers, but Margaret did find the love of her life, so maybe there's hope for me.
Well, she found the love of her life, but her love of her life...
No spoilers!
No spoilers, yes. She found the love of her life and the tolerance of her life.
It's a good way to put it. So maybe there's hope for me.
There may well be.
What kind of person do you think that I have to end up with?
Well, either a person you were head over heels in love with, that you were blind in love with, which you already have been, or a person that you are sufficiently comfortable with and respect well enough and can interact with easily enough without wondering what is this person thinking of, how slow is this person or how boring, that you would be happy. But again, it's all part of the probability of life, and there's always the issue of, well, I may meet this person, but how will I recognize him? If the person is very shy, how will I be able to interact with him both ways, interact with him and get a reading?
I'm shy too, believe it or not.
Well, I believe it, so am I. You can tell that, can't you?
Yes. But you and I, we have a special relationship.
That's because we communicate on more than just the superficial level, which when you're talking to a stranger, you're always doing. remember, when we're out among other people, we're always wearing our public mask, our public face.
I suppose that can be true, but I'd like to think I've never met a stranger, but I'm still shy. It's a conundrum. Whereas I've been in social situations with you, and you are indeed shy. You would just as soon you'd be the observer and not really, which isn't to say you're not lovely to chat with. I have eavesdropped on you having conversations with folks, but I think you are a little more to yourself, more reserved. You're more introverted. I'm an extroverted introvert.
You are very extroverted. You're very social, and you're like, not Mark Twain, but what was the early 20th century humorist? Oh, he made a lot of wise-ass jokes and stuff.
A satirist or a journalist?
More of a sarcastist.
That's a new word.
No, he was a great one-liner, and he would come on. He did a lot of stand-up comedy.
Will Rogers?
Will Rogers, and you're like that. More,
I would argue that I am more like, I've never met a person that I'm not curious about. Whether I like them or not, maybe the jury is out. But certainly my curiosity has always been the thing that I have followed.
Yeah, I'm afraid in my case, it only takes a few minutes of conversation to know that I'm not curious about this person at all.
I can always find something.
Well, good for you.
Let's get back to the universe.
All right.
One of my favorite things about you is that we can talk about so many subjects, and that delights me. The other day, we started a conversation about the edge of the universe.
Yes.
And for me to wrap my mind around the concept of the edge of something like the universe, it makes my brain cells start popping, because I picture this. Just you're walking along, suddenly you're at the end, and then what? What happens after that?
Well,
a Bed Bath and Beyond. What is it?
Yes. There's interesting. There's some theories about the origin of the universe and where that energy came from. Nobody really knows, but there've been lots of speculation and suppositions about what may have caused that, starting from who the hell knows, it just happened, to membranes, not multiverse, but membranes that in this 11-dimensional construct of the universe, we can think of membranes floating around, which are 3 dimensions plus time, 4-dimensional things in which each one is a universe into its own right, to whatever caused that Big Bang. It began with this enormous point of incredible, unfathomable energy. And since it was so energetic, you should ask the question, what did it appear in? Well, it appeared into the void, which means it is really a void. It isn't like what is outside what we call inner space, which is full of hydrogen atoms. It was a void. There was literally nothing there. And it expanded rapidly. But because Einstein pointed out, or since Einstein pointed out, that E equals mc squared, we know that a pile of energy is like a bunch of matter. They're equivalent. Matter and energy are equivalent. So you got a place here with this intensity of energy that is warping this void. And you can ask, if you like, well, what's it warping if there's nothing there? And you're getting into a second level of existence here. I don't know the answer. But anyway, all of a sudden that energy got converted to particles, which were fundamental. Now, yes, what does that mean? we don't know yet. We don't know where the limit of fundamental particles are. I mean, we've gone from atoms to nuclei and electrons to quarks and subquarks and, muons and what have you, and on and on. Well, from the time that I forget which Greek philosopher said that all of creation is made up of these indivisible particles called atoms, which in Greek means indivisible. They thought that was the smallest possible thing. And of course, a couple of thousand years later, we began to discover that no, in fact, things get smaller and smaller and smaller. Turned out that first batch of particles were interacting with themselves and with any, energy does create light, that you can generate light from energy, right? If you have excess energy in an atom, an electron is kicked up to a higher orbit in the atom, and it wants to get down to its more stable lower orbit. It decays and emits a photon of some sort, X-ray, gamma ray, whatever you want to call it, visible light, whatever. This great mass of stuff was producing particles which were reacting, emitting energy as light, which was being absorbed right away, and the whole mess was dark in the sense that nothing escaped by way of light or particles outside it. That was the known universe at that point, a few microseconds, up to maybe a few milliseconds, up to who knows, a few hundred years, thousand years, I don't remember. Until all these very fundamental particles finally combined enough to produce bigger particles that didn't absorb every bit of light that was trying to go through them, and everything lit up, and light now could get out, okay? But what happens when you've got a balloon full of energy, hot air? It wants to expand. And if this balloon is infinitely expandable, it'll keep expanding. It'll expand till the pressure inside is equal to the pressure outside. But in the void, there's no pressure. So as long as there's anything inside, it keeps expanding, which was a big controversy until Hubble, the astronomer, the observational astronomer, looked up and saw something really weird. He knew that stars were made from hydrogen fusion. And hydrogen has very particular wavelengths. And you look at those stars, you say, gee, those lights that should be hydrogen, there's a bunch of lights. They're all in the relative to each other, the right separation. But every one of them is a lot redder, a lot less energetic than they should be. Why? How could that be? Well, it's the train whistle effect. Train is coming at you, blowing its whistle, goes up in pitch. It gets to you, it's really high pitch, starts to go away, and the pitch goes down like a siren. So he says, well, the only this could be is that these things are moving away from us at some high speed, which you can calculate based on how much they're redshifted. And says, well, that's interesting because the stars that are closer to us have less redshift than the stars that are far away, which means the ones that are far away are moving away from us faster than the ones that are closer. And the only way that can be is if they're out there on the edge of this bubble, and the bubble's expanding, so any 2 points are moving apart, and they're moving away. So that gets back to the question, what's the edge of the universe? Well, it's whatever is out there. So how come we don't know it?
And what's containing it? And
what's containing it? There's nothing containing it. It is just what happens when you release a big burst of energy that wants to expand.
What's the potentiality of that expansion then turning back on itself?
Good question. Well, we can get to that in a minute. What I was getting at here, we were talking about what's the end of the universe or the edge of the universe. Well, that depends. That depends on how far out you can see. Because the end of the universe, as far as we're concerned, is where the farthest stars are that we can see. And since the stars farther away are moving away farther and farther, they get dimmer and dimmer because the light's getting redder and redder. And when it passes down below the energy we can perceive or detect, they, as far as we're concerned, no longer exist. That doesn't mean they're not there. It doesn't mean that it's still expanding and that the edge of the universe, the end of this bubble, isn't still there and moving away from it. But as far operationally as we can see, and we know our end of the universe is always as far as we can see. As I was saying last time, the new telescope, the James Webb telescope, is going to give us a deeper look. So our universe will now have a bigger size. If we could make a telescope made of, say, a few thousand square miles of, say, reflective mylar in perfect conformation to elect more light, we'd be able to see a lot further. Our universe will all of a sudden get a lot bigger.
Objects in this mirror are closer than they appear.
If we can detect the radiation redshifted so far that we can still detect it. If it gets redshifted down to sound level of energy, if it gets down to stuff only, that nothing on Earth we have will be able to detect it. To us, it'll be the end of the universe. Unless we build an instrument that can, in which case all of a sudden the universe will be bigger. Now, going back to the other question, that goes back to the debate of some 50 years ago or 100 years ago of whether the universe is contracting, static, or expanding. And that depends on what you understand to be the interaction between the expansion and gravitation. It was thought initially that it would expand and expand and expand until gravity slowed it down to a stop, then it would start coalescing again. But Hoyle and others thought, no, and Einstein even at some time thought it was a static universe, matter being created all the time and destroyed, and the universe was always static. And then Hubble came along and shot everything down and said, no, the universe is expanding and expanding, but nobody could really argue that. They still said, no, it's got to stop. Until Einstein said, oops, I made a mistake in my equations. And this doesn't make sense unless I put this term in. And he put in a term which he called the cosmological constant. And just the constant that describes this continuing expansion. And that made it consistent with what Hubble observed, and it predicted that the universe would keep expanding and expanding and expanding until what's called heat death, until everything had given up so much energy it was no longer moving, no longer interacting. We'd all sort of go to a state of eternal stagnation, of eternal, there'd be no energy left to do anything. So there was, or is, a theory which says that the Big Bang isn't unique to our existence, to our universe. It may have happened as a single huge explosion that was unfathomably bigger than our Big Bang, and it generated not our bubble, but an uncountable number of other bubbles, each one of which is its own universe. Each one of which is doing its own expansion thing. Each one with its own set of laws, and each one evolving its own way. To which one can say, that's nice, but not very useful, because we're stuck here in ours, and there's no way to get to theirs. So it may be right, it may be wrong, but it's not science because there's no way to prove it. No way to disprove it.
That theory is, which I tend toward, is one that is quite mind-boggling for me, because I think if everything happened at once and yet created all these different universes that are operating in their own way, but still similar enough to this one that there might be just little tiny variations.
There could easily be something with a minor variation. All that it would take might be that the energy requirement to make two amino acids link into a polymer, into a protein, is just high enough that lightning flashes and solar radiation wouldn't be enough to do it, in which case there'd be no life on the planet. Or it could be one in which every planet in the solar system was formed without a magnetic field, didn't have an iron core that was fluid, that was liquid. It cooled off too much and the iron core froze. That's what happened to Mars. When it was first formed, it had an iron core, it rotated, it had a magnetic field, and it could have had life. But planet is smaller than Earth by a certain amount. And if you look at the surface to mass ratio, it's just a little too big, too much surface amount of mass, and it radiated all the heat of the core away, and the core solidified, didn't rotate anymore, and the dynamo disappeared, couldn't generate the magnetic field, in which case it now became susceptible to the solar wind, lost the atmosphere, life died, and that was the end of it.
But don't we base the idea that if there are other universes, that we assume they're operating under our particular rules, because those are the rules we understand and know? I mean, isn't it possible that there's some planet like Mars where there was an adapted species that is like, we can take this, we don't care about solar winds, we're fine. Or maybe they live below ground.
You mean you don't need an atmosphere?
I mean, I'm saying, isn't it possible that somewhere out there is a universe in which the things that we understand to be true in our universe, there could be sentient life, fully functioning life elsewhere in another place that has beat what we would consider insurmountable odds?
As a fiction writer who grew up with science fiction and remembering the stories, there have been stories, that life depends on carbon.
Yes. In our understanding, it does.
Life in our world depends on carbon. Carbon has 4 bonds free and binds with so many things, itself and a lot of other stuff. Silicon is in the same periodic table of elements as carbon. Silicon also binds, but it takes a lot more energy to do it. It's a much higher energy process. That's okay, because there's a lot more energy radiation coming in from the sun, from cosmic rays and what have you. So it is conceivable. It is not beyond the rules of even science as we know it, that you could build a biology based on silicon, which perhaps would have a kind of metabolism and life cycle that didn't depend on oxygen or any other kind of gas that could be. It wouldn't be a biology we would recognize or on a planet that we could live on, but it would be possible, conceptually at least, to postulate a biology that evolves into a civilization, that evolves into a scientific community, that evolves into whatever. So yeah, sure, in a universe like that, or even in our own, it is conceivable, but it's only a theory, only a hypothesis, because there's no way at least know what we have now, to disprove it, to negate it.
Going back to what you said a minute ago about the void.
Yeah.
I think it's quite difficult for me to comprehend how something as magnificent as a universe coming from a void. And as you said, it is awfully odd to try and wrap your head around it. But you said something while you were talking about that was interesting to me. If we're three-dimensional beings that are we
four-dimensional, right?
Well, we of time being part of our reality, right? But also time is a construct as well. So it's sort of this, we're three-dimensional creatures living in a four-dimensional understanding. Is that fair?
We are three spatial dimensions, aware of what to us seems like the passing of time, but that is only because of our perceptions and our gross structure. We are not human beings that perceive the quantum world and can perceive space-time, because in order to really interact with space-time, you have to be of a mass large, like a planet or the sun, to warp space. And you have to be big enough mass to warp it significantly. And what you're warping has to be big enough to define how much mass you are and how you behave, what your mass behaves like. Einstein's general, the two halves of his equation, one side equals the other side, as it's described. One side tells space how to behave, and the other side, one side space tells mass how to behave, gravity tells space how to behave, mass how to behave, and mass tells gravity how to behave, or space warping and so forth. So it's the same thing. We're not, when we evolve, we're not big enough to sense that. All we are able to sense is the fact of entropy is really the only thing we can sense, i.e. we grow old or we decay.
And a sense of forward motion.
A sense of progression of yesterday to tomorrow. As we discover, as we grow up, we mature, we grow old. We grow up young and full of vinegar, and we're full of energy, and little kids skipping around and can't keep still, to the old folks who totter around and can hardly move. And then, it's the thing about our telomeres. On our genes have the instructions for life, right? There are the 4 nucleotides that in various combinations have all the information for making things alive. And at the end of each of the genes, which hold these strings of information, is a chunk of meaningless genes, which are at the ends of the genes, which somehow protect the genes. And every time a cell divides and it has to replicate the genes, it loses a little bit of the telomere. And as we get old and older and older, our telomeres get shorter and shorter and shorter. And as a result, instead of we're getting good replication of our cells, we get faulty ones. And so that's why we deteriorate. We can't keep renewing our cells properly. There are other things, of course, accidents and illness and one thing or another, that we can't repair. And so we die. So time is not this abstract thing, not this 4-dimensional construct. That's useful only in trying to write something which describes what the reality is at the quantum level, so we understand where the macro level comes from. But for somebody living in some nomadic tribe in the wilds of Africa, it's totally irrelevant. And they don't worry about it. They don't even know about it. All they know, they have babies, they have adults, and they have old people. and whatever problems that provides, they deal with.
If time is a mathematical construct, then wouldn't it stand to reason, again, hypothesis here, that we could just jot some mathematics down on a paper and time travel? Wouldn't that be fun?
It would be fun if fictional.
Of course, but the idea that the joke I'm trying to make is that
I understand it. I understand it completely. And it's equivalent to that old joke of Descartes. Remember Descartes says, cogito ergo sum? I think therefore I am. Someone says, Mr. Descartes, would you like a chocolate bar? And he says, I don't think, and vanished.
Exactly. Do you think there is a potentiality for time travel at some point in our existence?
What do you mean by time travel?
Forward. I would say forward travel, I suppose, right? Isn't it been proven that backward travel can't happen?
I don't think it's been proven.
Because of the conundrum it creates. Any type of traveling backwards would create even the butterfly effect, even the smallest movement.
Well, I can argue against that with the argument that says, if you did that and did something that was going to change history, that the flow of time is so resilient and so implacable that events would occur to negate any effect you might have had, and it would just continue on with a slightly different explanation, perhaps, of this little jog, but otherwise you would be in exactly the same reality as you did before you started.
Interesting.
That, in other words, you were able to create time travel only because of all the research, all the science that went on before you. And if you went back and shot the great-great-grandfather of the person who invented time travel, it would be invented by somebody else with the same name. The flow of reality can not be affected to the extent that you're proposing. Also, the information you may have gathered in the first instance when you went back wouldn't be there anymore, because time travel hadn't been invented after the reality readjusted itself.
But in that readjustment, wouldn't that make you not the person going back? Because all it would have to...
It doesn't matter that you're not the person going back. It only matters that you're a person going back.
Huh. It's a lot to chew on.
Well, I don't know. It just seems that fictional constructs of fictional universes are fine and they're fun to read. But for every fictional universe, the risk you run is trying to postulate something which immediately suggests all sorts of objections that can be raised that are just as reasonable as the universe you've created. And just as hard to prove or disprove. Well, to disprove anyway.
If there are other dimensions, can they leak?
That's an interesting question. And that leads to the question of why the heck is the force of gravity so much weaker than the other forces like electromagnetic force? And that's the thing. The force of gravity is many, many orders of magnitude weaker. Well, back at the Big Bang, all the forces were unified. They were all the same force. They were just special cases, And nobody has really come up with an explanation yet of why gravity is so much weaker than all the other forces. Gravity can be felt over the entire universe. The Earth's gravity goes out forever. It just gets weaker and weaker, like going over the square of the distance. But even close up, it's weaker. You can drop a ball and it hits the ground, but it takes time. If you shine your light beam down, light beam hits from the same tower piece. You could shine your flashlight down, and that light would hit the ground way before the ball got there. If you had a radio wave or a spark generator, the radio waves from the spark would hit the ground long before the thing you dropped got there. Force of gravity is very much weaker than these other forces.
That's true, depending on where you are on the Earth, even. If you're on top of a mountain versus at sea level.
Well, the force of gravity depends on the reciprocal of the square of the distance. And the distance is measured from the center of mass of the object to wherever you are. The center of mass of the Earth is somewhere in the neighborhood of the center of the Earth. Yeah. But this goes back to the question, actually, I was trying to get back to a leakage between the dimensions. There's been postulation, hypotheses about, that's sort of one of the hypotheses of what happened to gravity. It's leaking from our 3 dimensions to somewhere in those 4th dimensions by postulating certain geometric constructs of our universe that constrains the strong forces within these limits, but not the gravity. And most of the gravity is as strong as the other forces, but they leak out from our 3-dimensional or 4-dimensional universe or dimensions into these other ones, so we don't detect it. Doesn't interact with what's down with us.
But other things are not leaking for some inexplicable reason. If in that theory.
Well, there may be, but it doesn't affect the relative strength. I mean, the postulate I saw was that the other ones are constrained. There's sort of like an image of thinking of what happens to something which varies as the inverse of the square of the distance. Imagine these other forces are constrained between 2 planes, which bound our 3 physical planes we know about. And the strong forces, electromagnetism and so forth, are constrained within that. But gravity passes through it without reacting, which is as good an explanation as any. It just means that it's expanding like a sphere if it's not constrained within these bounds, whereas the other ones don't expand like the sphere because all their energy is constrained within by bouncing like a mirror, like 2 parallel mirrors. The light can't get out like it normally would do from a point source. It bounces back and forth and stays strong.
Understanding that hypothesis, is there a potentiality of a person walking along in their happy dimensional life and passing through a rip into another?
Well, unfortunately, all these constructs and concepts are really operational only in the micro world. Something as gross as a human being cannot go through the barriers. Made up of actual atoms and molecules and not fundamental particles. Fundamental particles are all buried within the particles, the real particles of molecules and atoms that make up are observable.
But technically isn't everything that is made up of atoms, which is everything, that it's just those things they're moving so quickly that they appear solid, but in fact they are not, and therefore could pass through?
The ones that appear solid like atoms only do that because the nucleus is so small and the electrons are so smeared out around them that mostly it's empty space. But that doesn't mean that the electrical field that surrounds the atom between the nucleus and the electrons isn't itself a big blob that keeps it from penetrating. But quantum mechanically, there is a probability, but it's so small compared to the probability of little particles doing things like that, that it is hundreds of times bigger than the age of the universe to happen. It's so small a probability that it would take many multiples of the age of the universe.
But you didn't say it's impossible.
Well, that doesn't make any sense.
So you're saying there's a chance.
No, I'm saying that the chance is so minute that you can say it's not zero, but it's indistinguishable from zero.
Obviously, you've never seen Dumb and Dumber because that was a reference from that movie. You are currently writing your 7th book about Margaret, the pirate. Can you talk a little bit about that?
Yes, well, Margaret actually started out in the first book as governess to the young children of an earl in England. And she had that job for 4 years. And because of the behavior of the earl's eldest son by his first wife, she was forced to flee, and she was heading for the North American colonies and wound up in the Caribbean and was rescued by a privateer because of incidents that happened. And her life sort of evolved from that, a life that she had never expected, never anticipated. And she became a pirate, a privateer. Her husband, she had a falling out because of a misunderstanding. She got her own ship with her own crew, and now she's captain, or became captain, of a crew of women, plus 2 previous harem guards who were, gelded, I think is a reference, which is what happens to palace guards before they become palace guards. Harem guards, not palace guards, but harem guards. And
meaning their testicles were removed.
Well, yes, meaning that mostly, for the most part, yes, sometimes it was more extreme than that, but in their case, yes. Through the course of the previous 6 books, she's had many adventures. She learned to be a master swordswoman, a master strategist, and she and her crew became extremely wealthy as a privateer, attacking and looting the ships of the one enemy she has. She and I have spent something like 6 years of her life.
What's that like to become so engrossed in a character? Or is she following you, or are you following her?
I'm following her. Yes. It was interesting. My first book, I was acting as a secretary, transcribing what she was displaying. It was like watching a movie. And this sort of progressed much the same way through the books. And by the 6th and 7th book, the interaction between the characters and the author became a little more complicated. But it was pretty clear that when the author wanted to have them do something, it just wouldn't work. So unless what the author was trying to describe as happening actually was what the characters were willing to let happen, it became very hard to write, which I found very interesting because I've heard of this before.
You fighting against your characters made it...
Not fighting against them. I don't think that's the right word. When I'm losing the connection, or when the connection's getting too weak or too separated. So it isn't that there's any conflict between the author and the characters. It's that I think the author is trying too hard.
How do you get back again then into the characters?
Well, if you're struggling because of something, you have to step back and let yourself actually accept what's going on and try to be logical, but not demanding.
Mm.
My feeling is you can't force a story. It's got to flow without feeling that you're just putting words on paper or on the screen,
Mm-hmm.
that you're actually there looking and being with the characters without actually being of the characters.
What made you decide in your retirement to do this as a means to take up your time?
Well, actually, I started writing a couple of mysteries. I wrote 2 mysteries. I joined the Pacific Northwest Writers Association, and at one of their meetings, there was a speaker who was telling the audience to stop worrying, just write. And a lot of authors apparently really agonize over writing, and he just said, "Stop doing that. Just sit down and write." And he said, "I'm going to put a couple of words on the whiteboard. I'll give you 10 minutes. Write something." So he wrote down pirate and woman. And in 10 minutes, I wrote a couple of, handwritten pages of a scene. And it turned out to be an idea for a story. It was a scene that would belong right in the middle of the 6, 7 books somewhere. But and that was the beginning. So I said, okay, that's interesting. How would I begin something like that? And when I got home, I wrote the introduction. What do you call that?
Prologue?
Prologue. Yeah. At my age, words seem to drift off into the never, never. A prologue. Would it be a spoiler to say what the prologue had in it?
I don't think so.
Anyway, she's in court being charged with murder, theft, and piracy. She's on trial for her life, and she's in front of a hanging judge without any jury. And this is the last in the last couple of decades of the 17th century. And she is testifying in her own behalf about what brought her to this point, trying to explain how her life came to this. Starting out with her standing in front of the Earl's home, the Earl's castle. Well, it's not a castle, but it's a stately home by then, and how she came to be in this court. And we went through the first book, and at the end there's a afterlog, whatever you call that.
Epilogue.
Epilogue, yes, and a sample of the next prologue for the next book, and the first chapter or so, and on and on. And it never seemed to really finish her story. And she had to keep the judge sufficiently interested in allowing her to keep continuing, because his typical trial lasted maybe no more than half an hour before the defendant was convicted and sent off to be hung. Hanged. People are hanged, not hung. Beef is hung, people are hanged, yes. And it went from there.
I don't want to take up all your day and tire you out. This has been such a great conversation, and I love you so much. And this is just a snapshot of the millions of conversations you and I have had over a lifetime together. And I'm so lucky to have you as a papa. I am so lucky. And I could not even begin to tell you how much you mean to me. Will you please let people know how they might find your books and such so that they can go seek out your wonderful brain?
Amazon.
Margaret, Outrageous Fortune, which is the very first book, is available on Amazon, as are the next 6 books, or I guess 5 more. There's 6 in total because you're writing 7. And they all can be found on Amazon under Martin March. The good news is I'm going to put all the links to all the books on Hey Human Podcast links page, so it will be very easy for people to go.
That's fine. Yeah, no, that's great.
Thank you so much for your time, Dad.
You're welcome.
I really enjoyed these talks.
And always keep in mind that I don't know what the hell I'm talking about.
Okay, I love you.
Okay, thank you. You too, sweetie.
I'll talk to you later. Thanks for listening, everybody.
All right.
Mwah. Bye.
Bye.
Rate, review, and subscribe to Hey Human on iTunes or wherever you get your podcasts. Thanks. Bye.